Namaskar children. Today we'll have a session on statistics. Statistics is a part of data handling as far as your syllabus goes. You're familiar with the fact that statistics is a branch of mathematics. It deals with collecting and collating raw data. And using statistical tools, it is possible for us to convert this raw data into information. And that is how we are able to analyze and interpret information. And this further helps us in the process of decision making. There are certain statistical measures that you are familiar with. Namely, in graphical techniques, you have worked earlier with pie charts. You are also familiar with the usage of bar graphs. Histograms are other statistical tools that you have used for visual representation. The lesser known graphical techniques are scatter diagram and also the technique of correlation. These are techniques which you will be learning later on as a part of this unit. The focus of today's class is mainly on numerical techniques. When we talk about numerical techniques, the first term that comes to mind is average. Average is basically a value which is a typical representation of the entire data. This average makes interpretation of data and comparison of data easier. The main keywords which you need to remember in numerical techniques are mean, median, and mode. You will be learning about these techniques in the coming session. Before we take an insight into these techniques, let us look at the usage of statistical measures which has been happening even in ancient history. This goes back to the time when farmers needed to estimate the number of fruits on a tree. The farmer would count the number of fruits on one branch and then multiply this by the number of estimated branches to get an approximate count of the total number of fruits on the tree. The statistical tool used at this stage is mean. In this slide, we will have a look at what mean is and how it is useful in analyzing data. Another example which can be quoted over here is, it goes back to the battle between the Spartans and the Athenians. The Athenians actually had to cross the Spartan wall, for which they needed an estimate of the height of the wall. The technique they used was that 100 soldiers would start counting the layers of the bricks at the same time. The logic was that although many of them were likely to go wrong, a majority of them would still get it about right. The average used in this case was mode. You will be learning about mode shortly and using it effectively. Coming back to the previous example wherein we talked about estimating the number of fruits on the tree, one point to be noted over here is the branch which was selected as a representative of the other branches was a branch which would somewhere lie in the middle of the branch which had the minimum number of fruits and the branch which had the maximum number of fruits. So the technique used over here was median. You will be learning about this technique as well. Before we move ahead with the measures of central tendency and talk about mean in particular, I would like to emphasize that each of these averages have their merits and demerits, and which average is best suited for analysis depends on the data and the type of interpretation that needs to be made from it. So let us now start with the first measure of central tendency, which is mean. Understanding mean is fairly simple. All we need to do is sum up all the values of the distribution and divide it by the total number of values. Let us do this for the example which follows. Find the mean of 8, 6, 7, 4, 9, 8, 8, 6, 7, 6 and 8. So by the definition of mean, what I'm going to do is add up each of these values. So 8 plus 6 plus 7 plus 4 plus 9 plus 8 plus 8 plus 6 plus 7 plus 6 plus 8 and divide all these values by the number of values. The number of values over here is 11 because I have 11 entries, 11 observations. Now this brings me to the sum as 77. So 77 over 11, which is an exact division and gives us the answer as 7. So there goes the answer into the answer box. The mean of the above data is 7. Our next example is also a similar one. Here we are looking at the ages of 11 football players and we need to find out the mean age of the players. So we again go by our definition. Mean is equal to sum divided by the number. So which means in this case, when I add up all the entries of 21 plus 23 plus 20 plus 27 plus 25 plus 24 plus 25, added another 30, 21, 22 and 28, the final sum comes out to be equal to 266. So this is again divided by 11. This division is not an exact one, and when we perform the division, we get the answer as 24.1818. So as per the exam system, we round off this value to one decimal place, which comes to 24.2. So which brings us to the final answer that the mean age of the players is 24.2 years. Alright, so now we have a question which is slightly different. The mean age of a group of 8 walkers is 42. Rick joined the group and the mean age changes to 40. How old is Rick? Let us analyze the data as old mean. So the old mean is given to be equal to 42. And then after Rick joins the group, we have a new mean. New mean, which is 40. So again, going by the definition of mean, 42 will equal sum of all the 8 walkers divided by 8, and on this side 40 would equal the sum of all the 9 walkers, because now when Rick joins the group, the number of walkers is 9 divided by 9. So from here I know that the sum of 8 walkers will equal 42 multiplied by 8, which equals 336. And from here I have that the sum of all the 9 walkers is equal to 40 multiplied by 9, which is equal 360. Now I know obviously Rick's age will lie in the sum of the 9 walkers. So Rick's age will actually be 360 minus 336, which is equal to 24. So that brings me to the final answer that Rick's age is 24. Okay, another example. The mean weight of 8 boys is 55 kg and the mean weight of a group of girls is 52 kg. The mean weight of all the children is 53.2 kg. How many girls are there in the group? Let me just denote X bar as the mean of all the boys. So which means the mean of all the boys' weight is 55 And I also know that the number of boys is equal to 8. And let me use y bar to denote the mean of all the girls' weight, which is 52. And I do not know the number of girls, so let me just presume that the number of girls is any variable, say p. I also know that the total average for the entire class equals 53.2. Okay, so now again going back to my basic definition, I can say this 55 will be equal to the sum of the weights of all the boys divided by 8, because the number of boys is 8. Which brings me to the conclusion that the sum of the weights of all the boys will equal 55 multiplied by 8, which is equal to a value of 440. Similarly, from here, I can say 52 is equal to the sum of the weight of all the girls divided by P. So which means sum of the weight of all the girls will equal 52P. From here, I can say 53.2 will actually equal the sum of the weight of the boys plus the sum of the weight of the girls divided by 8 plus P. Let me cross multiply and substitute values. So that brings me to 8 plus P multiplied by 53.2 will equal 440 plus 52P. When you solve this, we will finally come to a simple linear equation which gives us 14.4 over 1.2 and gives us the final value of P as 12. So which means we know that the total number of girls in the class is 12. Okay, so there goes an assignment question. Read the question, interpret it. I'm going to give you the final answer so that you can then make a tally and check that you are on the right track. That's another question for you. You need to find the value of x, and the final value of x will come out to be 9. Alright, so before we end, I'm going to give you a rhyme for mean. This will be a simple way of memorizing what a mean is. I'm not sure what the mean is about. Just add them all up and share them all out. Thank you.